What is the immune system? The immune system is a complex network of cells, tissues, and organs. They work together to defend the body against harmful invaders, such as bacteria, viruses, fungi, and other pathogens. Its primary function is to recognize and eliminate these foreign substances, during which it distinguishes them from the body's own healthy cells and tissues. The immune system operates through a series of coordinated processes that involve various types of immune cells, molecules, and specialized pathways. These processes can be broadly categorized into two main components: the innate immune system and the adaptive immune system. Innate immune system. This is the first line of defense and provides immediate, non-specific protection against a wide range of pathogens. It includes physical barriers like the skin and mucous membranes, as well as various immune cells like neutrophils, macrophages, and natural killer, NK, cells. These cells can quickly identify and attack invaders but do not generate long-lasting immunity. Adaptive immune system. This system responds to specific pathogens and develops a targeted response that is tailored to the particular invader. It involves a more complex process and takes a bit longer to activate than the innate immune response. The adaptive immune system relies on specialized immune cells called T cells and B cells. B cells produce antibodies, which are proteins that can recognize and neutralize specific antigens, molecules on the surface of pathogens. T cells, on the other hand, can directly attack infected cells. Memory cells are a critical aspect of the adaptive immune system. After encountering a specific pathogen, memory cells are formed. They allow the immune system to remember the pathogen and respond more rapidly and effectively if the same pathogen is encountered again in the future. This is the basis of immunological memory and the reason why vaccines work. They stimulate the immune system to create memory cells without causing the actual disease. The immune system's ability to distinguish between self and non-self is crucial to prevent autoimmune reactions, where the immune system mistakenly attacks the body's own cells and tissues. Overall, the immune system plays a vital role in maintaining the body's health and protecting it from infections and diseases. It involves a highly intricate and dynamic network of interactions that ensure the body's defense mechanisms are both robust and adaptable. What does the immune system do and how does it work? The immune system's main function is to protect the body from harmful invaders, such as bacteria, viruses, fungi, and other pathogens, while also distinguishing them from the body's own healthy cells and tissues. It achieves this through a series of complex processes involving various types of immune cells, molecules, and pathways. Here's how the immune system works. Detection and recognition. Immune cells, particularly white blood cells or leukocytes, constantly patrol the body, scanning for any foreign substances or abnormal cells. When a pathogen enters the body, immune cells recognize specific molecules on its surface called antigens. Antigens are like identifiers that help the immune system differentiate between self and non-self. Innate immune response. The first line of defense is the innate immune response, which provides immediate but general protection. Physical barriers such as the skin and mucous membranes prevent pathogens from entering the body. If pathogens breach these barriers, immune cells like macrophages, neutrophils, and natural killer, NK, cells are activated to attack and destroy the invaders. These cells use various mechanisms like phagocytosis, engulfing and digesting pathogens, releasing toxic substances, and triggering inflammation to eliminate pathogens. Adaptive immune response. If the innate immune response is insufficient to eliminate the pathogen, the adaptive immune response is activated. This response is highly specific and takes a bit longer to develop, but it creates long-term immunity. It involves specialized immune cells called T cells and B cells, which work in coordination. T cell-mediated immunity. Helper T cells recognize antigens displayed on the surface of infected cells or antigen-presenting cells, APCs. These T cells stimulate other immune cells and coordinate the immune response. Cytotoxic T cells are responsible for directly killing infected cells by releasing toxic substances. B-cell-mediated immunity. B cells produce antibodies in response to antigens. Antibodies are proteins that bind to specific antigens and neutralize pathogens. Memory B cells are generated, which remember the antigen for future encounters, leading to a faster and more effective response. Immunological memory. Both T and B cells generate memory cells after an immune response, allowing the immune system to recognize and respond more quickly if the same pathogen re-enters the body. This is the basis of vaccination, introducing harmless antigens to stimulate the immune system to produce memory cells without causing disease. Regulation and tolerance. The immune system is regulated to avoid excessive responses that could harm the body's own tissues. Regulatory T cells, TREGs, play a crucial role in preventing autoimmune reactions by suppressing excessive immune activity. Resolution and repair. Once the infection is under control, immune cells help to resolve inflammation and repair damaged tissues. The immune system's ability to adapt, learn, and remember is what makes it so powerful. It can protect the body from a vast array of pathogens and adapt to new threats over time. However, it's also a delicate balance, as dysregulation can lead to immune-related diseases and disorders. What are the parts of the immune system? The immune system is composed of a complex network of cells, tissues, and organs that work together to defend the body against pathogens and maintain overall health. Here are the main components of the immune system. Bone marrow. The bone marrow is a soft tissue found within bones. It is the site where immune cells, including white blood cells, leukocytes, are produced from stem cells through a process called hematopoiesis. The thymus is a gland located in the upper chest, just behind the breastbone. It plays a crucial role in the development and maturation of T cells, a type of immune cell that plays a central role in adaptive immunity. Lymphatic system. The lymphatic system consists of a network of vessels, lymph nodes, and lymphoid organs. It transports lymph, a fluid containing immune cells and waste products, throughout the body. Lymph nodes filter lymph and provide sites for immune cell activation and interaction. The spleen is an organ located under the ribcage, on the left side of the abdomen. It filters blood, removes old or damaged blood cells, and plays a role in immune responses against blood-borne pathogens. Lymphocytes. Lymphocytes are a type of white blood cell that includes B cells and T cells. They play a central role in adaptive immunity. B cells produce antibodies that bind to specific antigens on pathogens. T cells have various roles, including helper T cells that coordinate immune responses and cytotoxic T cells that directly attack infected cells. Macrophages. Macrophages are large white blood cells that engulf and digest pathogens, dead cells, and debris. They are part of the innate immune response and also play a role in presenting antigens to T cells. Neutrophils. Neutrophils are the most abundant type of white blood cell and are rapid responders to infections. They engulf and destroy pathogens through phagocytosis. Natural killer, NK, cells. NK cells are a type of lymphocyte that specializes in recognizing and destroying infected or cancerous cells. They play a role in both innate and adaptive immunity. Complement system. The complement system consists of a group of proteins that work together to enhance immune responses. They can mark pathogens for destruction, promote inflammation, and directly kill certain pathogens. Inflammatory response. Inflammation is a key aspect of the immune response. It involves increased blood flow, immune cell recruitment, and the release of chemical signals to eliminate pathogens and promote tissue repair. Antibodies. Antibodies, also known as immunoglobulins, are proteins produced by B cells in response to specific antigens. They bind to pathogens and neutralize them, marking them for destruction by other immune cells. These components work in a coordinated manner to recognize and respond to pathogens, eliminate them, and maintain the body's health. The immune system's complexity allows it to adapt to a wide range of threats and provide protection against infections and diseases.